In this animation, we will see what happens to the phase of a transverse wave after it reflects off of a surface. In order to keep the point of this animation clear, we will keep track of the incident and reflected waves separately. We will not show the times where the reflected wave interacts with the incident wave. This interaction can make the phase of the waves difficult to see. We start with an incident wave consisting of two crests labeled with a number 1 and a number 3, and one trough labeled with a number 2, traveling to the right towards a wall. Ideally, as the wave travels, its amplitude and wavelength will not change. However, in the real world, this may not be entirely true. To keep things simple, we will stick with the ideal case, as it does not change the result, and it just makes the result easier to see. As the incident wave strikes the wall, watch what happens to the phase of the crests and trough as they reflect off of the wall and move back to the left. The reflected wave will travel back to where it came from, in this case to the left. However, look at the reflected wave's shape. It has two troughs labeled with a number 1 and a number 3, and one crest labeled with a number 2. The reflected wave is exactly out of phase with respect to the incident wave. Every crest of the incident wave has become a trough on the reflected wave, and the trough of the incident wave has become a crest on the reflected wave. In the ideal case, the wavelength and amplitude won't change due to reflection off of a surface. Just the phase of the wave will change. In the real world, the wavelength and the amplitude may change. However, the phase of the reflected wave will change in the same way as in the ideal case. The reflected wave will now travel to the left, but 180 degrees out of phase with respect to the incident wave.